Hi guys, you're welcome to my channel. Today we are going to be talking about pressure in fluid, and I would like you to pay max attention to this class so that you can explain to your siblings, including your students. If you are yet to do that, don't forget to subscribe to this channel. And I really appreciate all subscribers and all viewers that has actually assist us to reach 2,000 subscribers. I really appreciate, but we can do better. Please, we are looking into how we can get to 10,000 subscribers in the next 2 months. I believe with you guys, with God, it's possible. Don't forget to give us a thumb if we actually deserve it, and don't forget to drop your positive comments. In case you have any question, you can also drop it there. Thank you. Now, when you talk about pressure in fluid, remember we've discussed the concept of pressure. If you are yet to watch the video, you can check the description box below. You find the links to the video there. We explained the concept of pressure, and I would like to recall it before I move into pressure in fluid. We said pressure is defined as thrust per unit area. And we define thrust, whenever they say thrust, we are talking about a perpendicular force. Whenever a force is perpendicular to a surface, we call that kind of force thrust. Do we understand this now? Cool. So, thrust per unit area is pressure. Take for instance, if I have this as a surface area, then I applied a force perpendicular to this area. This force is only in contact with this point only. So the area of this point divided by this perpendicular force will tell us the pressure exerted at this area. But we'll talk about that for solid. Now we want to see how fluid also exerts pressure. But before we look into that, I would like us to recall the concept of fluid. When you talk about fluid, you can either be talking about liquid or you talk about gas. When you say fluid, you are either talking about liquid or gas. Therefore, once you look at how liquid exerts pressure and how gas also exerts pressure, remember these two substances, or these two states rather, they don't have a definite shape. They give you the shape of the container in which they are in. Therefore, let's see how they actually exert pressure on that particular shape in which they are in. Let's consider the molecule of a gas. Let's say this is a container that contains gas, and these are gas molecules. All these molecules, they move randomly, and as they move randomly, they hit every part of the container. But when they hit the part of the container, the hitting is always perpendicular to the surface of that container. So, as they exert a perpendicular force on this container, we can call that force thrust. If we call the force thrust, if I consider a unit area like this, then thrust per unit area is going to be the pressure exerted at that area. Now, if all these molecules exert pressure at every part of the container, therefore we can say the liquid or gas, that is the fluid, because the same way it happens for gas is the same way it's going to happen for liquid. Therefore, we can say the fluid exerts pressure on every part of its container. Do we understand that now? Cool. We can see example of pressure in fluid in our day-to-day life. Let's take for instance that I have a balloon and I want to blow this balloon. I want to get a very big volume of it. All I need to do is to pass air into the balloon. As I blow air into the balloon will be increasing in size. Why is it increasing in size as I blow in air into it? Reason being that the molecules of the air that I'm blowing inside the balloon keep eating the wall of the balloon. As they keep eating the wall of the balloon is increasing in size. And that increase in size will continue as long as I'm increasing the numbers of air molecules inside the balloon. Now, the balloon will keep on increasing until it gets to its elastic limit. So, when the balloon gets to its elastic limit, then it bursts. Are we together now? Therefore, we can see that it is as a result of the pressure in the balloon that causes what? The increment of the balloon. Cool. Let us also see a container that contains a liquid, for instance, water. If I poke the container, take for instance that I have this. If this container should contain a liquid and I close it at this end, mind you, the liquid itself not to go to anywhere, it will remain here, right? But if I perforate it here, you start seeing the liquid rushing out from this place. Why is the liquid rushing out from this place? Cool. Before I explain that, if I use my hand to block what? The liquid from coming outside, you'll be seeing that what? My hand is feeling some certain force exerted by the liquid. Are we together now? That force is actually perpendicular. You know, this is my finger stopping it from coming outside. Then you'll be seeing a force. I'll be experiencing some force on that finger, which shows that the molecule are actually eating the container. Are we together now? Now, if I remove my hand, you see the water coming out again. Why? This is because as at when the water is full, are we together now? The pressure in this particular container is quite higher than the atmospheric pressure. As it is higher than the atmospheric pressure, that causes the fluid to flow out. Are we together now? The pressure inside this container is higher than the atmospheric pressure. That is why you see the liquid rushing out from the perforated part here. What can we deduce from this? Aside from the fact that we've understand that actually liquid also exert pressure, we can also what? Deduce the fact that pressure flow from a region of higher concentration to a region of low concentration. If you don't understand this, let me quickly recall when we are talking about temperature. We said when we have a body whose temperature is 50 degrees Celsius and we have a body whose temperature is 5 degrees Celsius, obviously this one is hot while this one is cold. Are we together? If you bring these two bodies together, heat is set to transfer from the hot one to the cold one. The same thing goes to pressure. Are we together now? Fluid flow from a region of high pressure to low pressure. So the flowing of fluid has to do with the difference in pressure. Likewise, the flowing of heat has to do with difference in temperature. Do we understand that now? So if a fluid will move from one place to another, it must be from a region of high pressure to a region of low pressure. And that is why you see the water coming out from the perforated parts. Do we understand this now? Cool. If we understand this, How then can we measure pressure in fluid? To measure pressure in fluid, we also go back to the formula of pressure. Remember that pressure is actually a perpendicular force divided by the area in contact. Now, if I have a solid, let's say I have this solid like this on a table. Now, this solid has a mass m. Now, when I place it on the table, the weight of this solid is acting perpendicular to the surface of that table. Are we together now? And this weight is given as mg. Are we together now? Now, let's say the weight of the molecules of fluid is also given as mass times gravity divided by the area. How can I get the mass of the fluid? Remember, if I want to get the mass of this solid, I can easily place it on my chemical balance, or what we refer to as beam balance. Then I'll get the mass of it. But I can't do that for a fluid because they are shapeless. If I intend to do that, I will take a long process by measuring the container size first. Then when I put the fluid inside it, I will take the measurement again, then take the difference. That will give me the mass of that particular fluid. But instead of doing that, we can act very smart. Remember that if an object is heavy, an object is what? Light. There is something that can actually explain why some objects are heavy and why some are what? Light. Let's quickly what? Look into that. If I have a volume of 3 centimeters for a water and iron, that is, the water is 3 centimeter cube and the iron is also 3 centimeter cube. Which one do you think it will be heavier? Thank you. It will be the iron. Why will the iron be heavier? Because of a certain factor, and that factor is what? The density. Are we together now? So, if it is water that is heavier, it shows that what? The density of water is greater than that of the iron. And if the iron is the heavier, it shows that the density of iron is greater than that of the water. And that shows that we can use the density to determine the mass. Okay? So, I can then recall that density rho is equal to the mass of a substance divided by its volume. If I cross multiply, I have density times volume to give us what? Mass. Am I making sense? So mass of a fluid is equal to its density multiplied by its volume. So I will then use this now to substitute for m in this equation. Let me call this equation 1 and I'll call this equation 2. Why this is equation 3. So I'm using equation 3 to rewrite equation 2. Therefore, I have my pressure to equal mass. Instead of mass now, it becomes density times volume times gravity divided by area. Now, volume can also be height times area. Are we together now? Because area is length times breadth, and we know that our volume is length times breadth times height. Length times breadth gives us what? Area. So we have area times height is volume. Then I can use this to replace volume here. I therefore have that pressure equal what? Density multiplied by area multiplied by height multiplied by gravity divided by area. So the area we cancelled area. Therefore, I have that pressure equal density multiplied by area multiplied by gravity. So this is going to be the pressure of a fluid. Do you understand that now? So pressure in fluid is given as the density of that fluid multiplied by its depth. Mind you, this is not an altitude. This height that you are seeing here is not altitude, but depth multiplied by gravity. Now, there is a say that says that The pressure in fluid increases with depth. How do they mean? Let's quickly consider that before we call it a day on this lecture. Let's take for instance that I have a container that contains a liquid. Okay? I think I should use something like a column. Now, let's say this is the surface of the liquid. That is, the liquid gets to this point here. Now, when you talk about the height h, this is the height h that we are talking about. And this height is not the height of this cylinder, but the height from the base of the cylinder to the surface of that particular fluid. That is the height from this top of the fluid of the fluid downward. Now you will see that as the liquid, as the depth increases, you will see that pressure is said to increase. If you look at this region, the number of molecules that we have here, if I'm considering the pressure on this region, the pressure at this region, I have to consider the force that all these molecules are exerting on this place. Unlike if I only want to consider the pressure here, the only force I will consider is just the one at the top of it, which is not as much as when I'm considering everything here. And you know that if force should increase, pressure would also do what? Increase. That shows that as you go downward, the number of molecules increases. As the number of molecules increases, the pressure also what? Increases. That is why we said that depth increases what? Pressure. That is, pressure increase with depth. And you can also see from this equation, only that you might make mistake of calling this h height or altitude. This is called depth, not the altitude. So if you look at it now, the density of a fluid is constant, and that of acceleration due to gravity is also constant. Therefore, pressure is directly proportional to depth. Do you see that now? That is, if depth increase, pressure would increase. Okay? What will now happen if density of a substance should increase? If density of a substance should increase, the pressure would also do what? Increase, because that will result to an increase in mass. Are we together now? So, this is where we are going to stop for this class. By His grace, in our next class, we'll be talking about atmospheric pressure and barometer. So when you talk about barometer, it is an instrument that we use in measuring the atmospheric pressure. We talk about the atmospheric pressure itself, and we talk about barometer. Then we also look into manometer. We can now start considering some laws that govern pressure, either in fluid or in solid. Example, the Pascals, the Bernoulli, and so on like that. We'll be considering all those things. Then we'll start looking at questions and their applications. Now, before I leave, let me ask you this question. Why is it that if you go to restaurants to get a drink, if you are given the drink and you put straw inside that particular drink, none of the liquid or none of the drink components, like let's say Coke now, you will not find any Coke inside the straw. But immediately you put your mouth to suck it, the liquid flow into the straw. What happened? Why is it like that? Let me know what your answer will be in the comment section below. I believe my question is clear. Let me take it again. If this is a straw, and here is what? My Coke. If I put this straw inside the Coke, you will not find any Coke inside the straw until I use my mouth to suck the straw. Then you find some Coke passing through it to my mouth. Why is it like that? Why is it that if I don't suck, the Coke will not enter inside the straw? And why is it that when I suck, the Coke entered through the straw? If you are yet to subscribe, don't forget to do that. Love you guys.